Here we have a problem which requires that we manipulate fractions. It is somewhat cumbersome, but it is like a typical problem that we have on our examination. What we will do first is convert the mixed numbers to improper fraction. That is a general way of doing it. That's not the only way, and in some cases it might not be the best way, but generally converting to mixed numbers will simplify our work. We will begin our attempt at solving this problem by first converting the mixed numbers to improper fractions. And the first one that we have is 1 4/5. We first label the components of the fraction, the numerator, the whole number, the denominator. As a reminder, also that our younger viewers will be able to comprehend and will be able to follow this exercise quite readily. Multiply the denominator by the whole number, then add the result to the numerator. So first we multiply the denominator by the whole number, and of course we have them labeled. So it is 5 times 1, which is equal to 5. Then we will add the result to the numerator. The numerator is 4. 5 is then added to 4. The result is 9. Now that 9 will be the numerator of the improper fraction, and the denominator will be the same as before. We don't need to take a second go at this one because we have a second improper fraction right here. So our second chance will be taken on this one. So we'll take the 2 2/5, and we'll go through the process again. First, labeling all of the components of the number. Then we will go straight ahead. Multiply the denominator by the whole number, and then we will add the result to the numerator. The denominator times the whole number, which is 5 2s 10. Then we will add that 10 to 2. After doing that, then we will have the numerator of the improper fraction, and the denominator is going to be the same. So there's no difficulty with that. As a matter of fact, on subsequent audiovisuals, we'll look at the reason for doing this exercise in arriving at our improper fraction. All of that will be done in graphic detail so that we'll get to the real foundation, to the very foundation of the reason for taking a step like that. It is not just a matter of completing an exercise, but in a subsequent audiovisual, the finer details will be explained entirely. Now we'll go straight ahead and manipulate the expression. We will replace the mixed numbers with their improper fractions equivalents. The 1 4/5 will be replaced by 9/5, and the 2 2/5 will be replaced by 12/5, or we just say 12/5. We have done that. Here, the fraction in the numerator, which is this large fraction, well, this large numerator will be enclosed in brackets, and the large fraction bar, which is this one, will be replaced by a division sign. Now what this does is that it prevents our work from being too hilly. That means from going in a vertical direction too quickly. That means it will take less pace in solving the problem like this, rather than continuing with the numerator being large and we have another fraction below, so we put the other fraction beside. And in order for us to do that, we will have to make use of a large bracket to say that we are dividing all of what we had previously in the numerator by what we have right here. Now we'll go straight to this. Adding or subtracting fractions with denominators that do not have a common prime factor may be done as follows. So we will demonstrate a very quick way to add or subtract fractions when the denominators do not have a common prime factor. As a matter of fact, it will work for all cases. It is just that when they do not have a common prime factor, the result will be in its lowest terms. And that is why we are focusing the entire exercise, zeroing in on the fact that the denominators do not have a common prime factor. It may be done for any kind of denominators, but if the denominators have common prime factors, the result is not going to be in its lowest terms. Our denominator will be the product of the two denominators. Then the next one will be the leading diagonal. We multiply those numbers, 9 threes, and the result is 27, and we'll go for the subordinate diagonal, 5 ones, 5. We'll go there. We are dividing by this fraction, and we know that dividing by a fraction is equivalent to multiplying by its reciprocal. We will therefore multiply by 5/12 or 5/12, which is the reciprocal of this fraction. Then we may go straight ahead with the simplification process. First of all, 27 minus 5 is equal to 22, and we may simplify by a common factor of 5 in the same step. So we are going to say that this is 22, and we are going to simplify by a common factor of 5 in the same step. So 5 into 5 is 1, and 5 into 15 is 3. The result will therefore be, of course, 22 over 3, and we'll have 1/12 here. Don't forget, simplifying by a common factor of 5, and of course 27 minus 5 is equal to 22. We will further simplify by a common factor of 2. 2 into 22 will be 11, and 2 into 12, that will be 6. So we'll have 11 over 3 multiplied by 1/6, and we'll multiply the numerators, and we'll multiply the denominators finally, and that will be our final result. 11 ones, 11, and 3 sixes, 18, and that is our final result. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.